Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 714. Page 714, please turn to it. And today is our lesson number 82. Listen, before I start the problem number 7 that you see there, yesterday in the lecture I used a word which is still on the blackboard here, moot point. And I forgot to tell you the day number when we learned that word. It is day number 7. If you're interested in learning what a moot point is, just type in vocabulary, day number 7, and you will find it. A moot point is something, a point that is discussed purely for theoretical purposes. Something that has no practical implication, something that has no practical importance, is discussed purely for theoretical purposes, is called a moot point. Yesterday we were talking about simple square. We were doing problem number, if you turn to the previous page, you will see problem number 6 there. And we were doing in problem number 6, we were discussing numbers that are called simple squares. And we came across, and we had several different answer choices there. For example, we were looking at 33. The factors of 33 are 1, 3, 11, and 33, of course. And what I said is that the fact that neither 3 nor 11 happens to be square root of 33, because that's the condition. A simple square is one which has 3 factors. 1, of course every number has a factor of 1, itself, which of course every number does. Every number can be divided by itself. And in addition to that, the third and only other factor of a simple square is a square root. And the point here is not that neither 3 nor 11 happens to be square root of 33. That is not the point. That is actually the moot point. That the point here is that it has 2 other factors in addition to itself, and 33. It's supposed to have one other factor. So before we even worry about whether or not the other factor is the square root or not, the fact here that there is more than one, that's the end of it. So the other one was a moot point. Anyway, I don't quite remember exactly how I used in the context, but if you watch yesterday's video, you will see it. But that was the word there. I put it on the blackboard, and I forgot to tell you which day to find it. It's day number 7. Problem number 7. Problem number 7 in 714. We're given a triangle here. X, Y, and Z. This is a perpendicular. I shouldn't have drawn this a solid line. This is the height. And because it's the height of the triangle, it's the perpendicular. That's how we find the height of a triangle. Height of the triangle means exactly what it says. Height of a triangle means you go to the highest point in the picture and you ask yourself, how high is it from the floor? How high is it from the base? By dropping a perpendicular. In this triangle we are told that x to z, which is the base, we are told that the base of this triangle, which is x to z, happens to be 6/7 of height. What does off mean? Off means times or multiply. For example, if someone says half of 8, well, half of 8 is 4, because half of means times. Half times 8 is going to be 4. Of means times. So here we are told that x to z, which is 6/7 times the height. What is the question asking? What's the area of XYZ in terms of h? Alright, let's find the area. area of any triangle for that matter is simply equals 1/2 base times height. 1/2 base, but we know that base equals 6/7 of height. So let's put it in here. Base equals 6/7 of height times the height itself. You see, 1/2 base times height. That's it, we're done. 2 can cancel out with the 6, becomes 3, and we end up with 3/7 times h, which is 3/7 times h squared. That's our answer. The area of this triangle is 3/7 of the height of the square of its height. Whatever its height is, you take a square of it, and the 3/7 of that amount is this area. And the answer is B. The answer is B. Make sure you pick B and not C, because in C, h is not squared. We need h squared because it is h times h. It's going to give us h squared. That was it. That was number 7. Let's take a look at number 8. Number 8. Number 8, we are told A and B are positive integers. Alright. A and B are positive integers. And we are also told that A raised to half times B raised to 1/3, and we take a 6th root of it, and if we do that, we are told that that happens to equal 432. They're basically looking to see here if you know how to manipulate your exponents, which is a very important topic and is covered on the SAT all the time. Every exam has few questions dealing with the concept of exponents. The question is, what's the value of A times B? Alright, so somehow we have to get A times B by itself out of this thing, out of it, because they're asking us how much is A times B. So somehow we have to get A times B out of itself, out of this mess here somehow. Let's find out. 1/2 A raised to 1/2 A raised to 1/2, and that quantity is raised to 6, which can be written as A raised to 1/2 times 6, because when you have exponents, P raised to 2 squared is not 2 raised to 5, it is P raised to 2 times 3, of course. So it's half times 6. Similarly, B raised to 1/3 times 6. And this 2 will cancel out with this 6, it will become 3. So it's basically A cubed times, and this 3 will cancel out with the 6, and which gives us B squared. Now we're going to get A times B out of it. Let's get A times B out of it. So this can be written as A times B. And that all of this, we are told, equals 432. 432. 432. We're going to pick up our story from here on the top here. I need the room, so I need to raise the top part. A times AB equals 432. And the question is, what is the value of A times B? Well, let's try something else, see what happens. Let's see if A can equal to 2. Let's pretend A equals to 2. If A equals to 2, oh, I left something out, shouldn't it? It's A times, when we take out A from it, this should be A squared times B squared. I left something very important out. This would be, let me do it properly. So this A cubed can be written as A times A squared, and this is B squared, which can be, when we take out when we take out, that's it. This can be written as a times a squared times b squared, which of course is same as a times ab squared. And this, we are told, equals 432. That's the part I left out. I forgot the power there, the exponent. Because as I reached here, I realized that my story wasn't going to make sense unless we have this quantity as a perfect square. This is a square. So let's pretend that a is equal to 2, and we'll see if that works. If a happens to be 2, then 2 times ab squared equals 432. We divide both sides by 2, and we find that how many 2's in a 4? 4 has 2 2's. How many 2's in a 3? 3 has 1 2. The remaining one goes and joins this 2, becomes 12. How many 2's in a 12? 12 has 6 2's. And we end up finding what we find is that a times b squared equals 216. Now do you see a problem here? The problem here is that this quantity a is an integer, we are told. I erased it. A is an integer and b is an integer. These are whole numbers, a times b. Since a is a whole number and b is a whole number, therefore a times b is a whole number, which means square of some number equals 216. But that is not possible. Square of no number equals 216. It is not possible. 216 is not a perfect square. That would not work. We cannot pretend that a is equal to 2. A cannot be 2. Let's try 3. Shall we? Let's try a equal to 3. Let's pretend a is equal to 3. See what happens. So 3 times ab squared equals 432. Divide both sides by 3. This 3 cancels out. And let's divide 432 by 3. How many 3's in a 4? 4 has only one 3. The remaining one goes and joins this 3, becomes 13. How many 3's in 13? 13 has 4 3's. 4 3's are 12. The remaining one goes and joins this 2, becomes 12 again. How many 3's in a 12? 12 has 4 3's. And we get 144. So now we have a times b squared equals 144, which is a perfect square. Which is a perfect square because 144 is 12. 144 equals 12 squared. And there you go, we have our answer. How much is a times b? A times b equals 12. This implies that a times b equals 12. And that's it. That's our answer. The question was, what's the value of a times b? And the answer is 12. A times b is 12. Now we do not know the value of a and b. We have no way of knowing which one is 2 and which one is 3. All we know is that when you multiply them, because they are whole numbers, because they are integers, we know for a fact that one of them is 3, the other one is 4, because 4 times 3 is 12. But based on the problem that we have done here, if they had asked us what's the value of a, all we can say is that a is either 3 or a 4. If they ask us what's the value of b, all we can say is that b is either 3 or a 4. We cannot tell which one is 3 and which one is 4, but that's not what they're asking here. They're asking us what's the value of a times b. Well, then in that case, it doesn't matter whether it is 3 times 4 or 4 times 3. The answer is 12. And the answer is B. Answer is B. That's it, we are done. I will see you tomorrow, okay? Bye now.